Hello everyone, myself Vinay Kumaram. I am pursuing PhD in physics. So in this particular YouTube channel, I will be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my previous video, I was actually explaining about the operation on real numbers. More specifically, we discussed about operations between two irrational numbers, and also we discussed about operations between one rational number and one irrational number. So that is addition, subtraction, multiplication and division. So in this particular video, we will try to explore exercise 1.4. So the remaining examples which are there here, like example 16, 17 and all. So these examples, if you want to understand, I will be discussing the exercise questions, that is exercise 1.4 questions. So if you understand all the questions which are there in this particular exercise 1.4, the examples also you can just refer on your own. So before starting exercise 1.4, let me recall whatever I have taught in the previous video. Whenever you perform operations between an irrational number and a rational number, or rational number and irrational number, then so here I am doing addition operation, here I am doing subtraction operation, and I am doing multiplication operation, and I am doing the division operation. So whenever you perform these operations between rational number and an irrational number, so always you will get irrational number only. So this you should remember. And whenever you perform operations between two irrational numbers, that is if you are taking one irrational number and two irrational number, and then if you go on doing plus, minus, into or division, so these operations if you are performing between irrational number, two irrational numbers, then you might get either rational number or you might get irrational number. So either of this you will get. So remember this before solving the exercise questions. So now we will move to the first question in this particular exercise. Here you have to classify the following numbers which they have given in this exercise, in this particular first question, as rational or irrational numbers. So the first question in first question is 2 minus root 5. So here you can clearly see 2 is a rational number and root 5 is an irrational number. So you are performing operation between, that is subtraction operation between 2 and root 5, that is between a rational number and an irrational number. So this will give you irrational number. So here I have explained that whenever you perform operations between a rational number and irrational number, so always you will get irrational number. So here also you have done the subtraction between a rational number and an irrational number. So this entire term, that is 2 minus root 5, is an irrational number. So now coming to the second question in the same first question, here they have given 3 plus root 23 and minus root 23. So now we will perform this particular operation. So here this is irrational number and this is also irrational number. We will just remove this particular bracket. So when you remove the bracket, it is 3 plus root 23 minus root 23. So here root 23 and root 23 can get cancelled with each other, because plus root 23 and minus root 23 will give you 0. So 3 plus 0 is 3. So you are getting answer as 3, and we know that 3 is a rational number. So that means this entire term, that is 3 plus root 23 minus root 23, is a rational number. So in first question we got an irrational number, in second question we are getting a rational number. Now moving on to the third question, here they have given 2 root 7 divided by 7 root 7. So here root 7 can get cancelled with each other, so 2 by 7 will be remaining, which is a rational number. So that means 2 root 7 divided by 7 root 7 is a rational number. So now coming to the fourth question in this same first question, here you have 1 by root 2. So here you can clearly see 1 divided by 1.414, it goes on like this. So you have irrational number in the denominator. So this entire term will become irrational number. So this 1 by root 2 is an irrational number. because here you can clearly see 1 is rational number and root 2 is irrational number. So that means you are performing operation between rational number and irrational number. So rational number divided by irrational number will always give you a irrational number. So that's why 1 by root 2 is an irrational number. So now coming to the fifth question in this particular first question, here they have given 2 pi. So here you can see 2 is a rational number and pi is an irrational number. So rational number multiplied with irrational number will always give you irrational number. So that means here 2 pi is an irrational number. In second question, you have certain terms which you have to simplify. So looking at the first question in this second question, here you have 3 plus root 3 into, so this is there in bracket, into 2 plus root 2. So now you can multiply this. So you can multiply 3 with 2 and also you should multiply 3 with root 2. And root 3 should be multiplied with 2 and also root 3 should be multiplied with root 2 as well. So 3 into 2 is 6 plus 3 into root 2 is 3 root 2 plus root 3 into 2 is root 3 2 root 3. Root 3 into root 2 is root 3 into root 2. When you have root m into root n, this is always equal to root mn. So here in the place of m we have 3 and in the place of n we have 2. So that means root 3 root 2 will be equal to root of 3 into 2, that is root 6. So in this place I can write root 6. So final expression you can write as 6 plus 3 root 2 plus 2 root 3 plus root 6. Second and third question you can solve on your own. I'll solve one more problem in this second question, that is fourth one. So in fourth problem you have root 5 minus root 2 in the bracket and in the second bracket you have root 5 plus root 2. So now you have to multiply this. So here root 5 should be multiplied with root 5 and the same root 5 should be multiplied with root 2 and this minus root 2 should be multiplied with root 5 and minus root 2 should be multiplied with root 2. So we'll do that. So this is equal to root 5 into root 5 plus, here plus root 5 is there, plus root 2 is there, so plus into plus is plus, so plus root 5 into root 2, here minus root 2 into plus root 5, so minus into plus is minus, so root 2 into root 5 is root 2 into root 5, minus root 2 into plus root 2 is minus root 2 into root 2. So here as I explained, when you have root m into root n, you can write this as root mn. So that means here root 5 into root 5 is there. So I can write root 5 into 5. Inside a single root, I can write 5 into 5 plus root 5 into 2 minus root 2 into 5 minus root 2 into 2. So 5 5s are 25 plus 5 2s are 10 minus here also 2 into 5 is 10 minus 2 into 2 is 4. So here you can see plus root 2 and minus root 2 is there. So these two gets cancelled with each other. So only term which is remaining here is root 25 and minus root 4. So that means here we are getting root 25 minus root 4. So root 25 is 5, root 4 is 2. So 5 minus 2 is 3. So coming to the third question, here we all know that circumference of a circle, so let's say small c is the circumference of a particular circle and small d is the diameter of circle and small r is the radius of the circle. So circumference value is always equal to 2 pi r. So 2 times radius means it is nothing but diameter. So that means I can write this as pi into d. So c, that is circumference, is equal to pi into d. So c divided by d gives you pi. So here you can see whenever you measure circumference and whenever you measure diameter, you have a certain rational number. So that means let's say circumference of a particular circle is 3.4 centimeter and diameter some value will be there. So that means the value what you are telling for circumference and the value what you are telling for the diameter of this circle, both are in rational number. But here these rational numbers, you are taking division between a rational number and a rational number. So that means you are dividing rational number with rational number, but that is equal to an irrational number. This is not possible because whenever you do a division between rational number and rational number, you will always get a rational number. So this is always a condition of rational number, where if you divide a rational number with a rational number, you will get a rational number only. So, but in this case, when you are dividing rational number with rational number, you are getting pi. So this is making a contradiction. Is this really a contradiction? And if it is not a contradiction, how can you justify this? So that is what they have asked in this particular third question. So now, let me tell you one thing. Whenever you are measuring any length, whenever you are measuring, what you are measuring. So for example, I draw a line like this. Let's say this is the diameter of circle, and the one end of this diameter is known as A and the other end of the diameter is known as B. So now from what point you are actually measuring on the scale? So on macro level, you will just approximately keep one particular ruler scale and you will measure the length between A and B. So you will measure the length between A and B and you tell this particular length is a rational number. So how can you tell this particular length is a rational number? Because you are measuring from point A to point B. So what exactly is the point A? You don't know. What exactly is the point B? You don't know. You might tell this is point A. You might tell that this point is A and this point is B. But if you ask me, whenever you are considering length, from what level you are starting with? So for example, if I zoom this particular line, so now I'll draw this line in another slide. So let's say this is AB, which is diameter of a particular circle. So when I zoom this particular part, there will be so many thousands of atoms present in that particular point. So in this same point, there will be so many atoms present. So if I even zoom the atom, there are so many subatomic particles. So from what position you are actually starting your measurement, and at what position you are actually ending the measurement. So in macro level, we can just say I am starting from this point and I am ending at this particular point. So I am taking distance between A and B. So in macro level, it is okay. When we go to the atomic level, exactly from what point you are measuring the length. So there you have to consider that level accuracy while taking the length. So that means whatever length we are measuring is not exact value. So it is always an approximate value. To make our calculation easier, we take approximate length. So to make calculation easier, so the length value is approximated. So the length value is approximated. So that means whatever length you are measuring using your ruler scale, it will give you some approximate length. It will not give you the exact length of that particular diameter or of that particular circle. So that means circumference, if you just open the circumference of a circle, that will also become a straight line. So from what point to what point you are measuring that particular length. And also here diameter, from what particular point to what particular point you are considering to measure the length. So that's why always there is possibility of error in measurement of length. So that's why we take approximate value of length. So when we take approximate value of length, that means this particular C is not a rational number and this particular D is not a rational number. Rather, it is an approximate value. So rather these are approximate value. So that's why whenever you are actually considering the length of C and D, they are not exactly what you expect. So always there might be chances that you end up with an irrational number. So that's why the value of pi is irrational, because you don't know the exact length of circumference and diameter. So whatever length you are measuring is just an approximate value. So this justification, if you want to understand, you can watch this particular video multiple times. This particular question what I have explained, you can watch this multiple times to understand this particular third question. So in your own words, you can answer this particular third question. If you understand the core concept of this particular third question, then you can come up with your own answer for this particular third question. Coming to the fourth question, here you have to represent 9.3 on number line. So that means here in the previous video, I have explained how to locate 3.5, root 3.5 on number line, where after that I generalized this by taking 3.5 as x, and I have generalized root x, how to locate root x on number line. So if you follow my previous video, how to locate root 3.5 on number line, similarly you can locate this particular root 9.3 on number line. So the simple thing what you should do is, you have to draw a particular line AB which has length just 9.3. So 9.3 length, and from this particular B you can extend this up to C, and this particular B to C you can consider this as 1 unit, and you can draw a semicircle like this, and you can draw a perpendicular line to this AC starting from B and intersect this particular semicircle circumference. So now you can consider the center point of this particular entire length AC. So that will be somewhere here, and you can call this as O, and you can call this point as D, and you can connect this OD, and you get a right angle triangle. So you can calculate what is the length between OB, and you can calculate what is the length between DB, and this DB will be root 9.5, because here you have root 9.3, because here you have considered 9.3 as the length between A and B. So these things I have explained in my previous video while calculating the locating the root 3.5 on number line. So similarly you can do here also. In the place of taking 3.5 as the length between A and B, you can take 9.3 as the length between A and B. So thereby you can calculate this particular value for dB, that will be equal to root 9.3. Then you can place this particular semicircle on number line in such a way that B should come at 0th position and C should come at 1 position, because the length between B and C is 1 unit. So then you can draw a particular circle for this BD, and you can locate where exactly on the number line this particular circle is meeting, the circumference of the circle where BD is acting as the radius. So that circle, wherever it is meeting on the number line, so that position will be your root 9.3 value. So this I have explained in detail in my previous video for root 3.5. You can refer that. It will be easy for you to locate root 9.3 on number line. Coming to the fifth question, here you have to rationalize the denominators. So looking into the first question, here you have 1 by root 7. So you have to rationalize the denominator. So that means this entire term is an irrational number, because here you have rational number divided by an irrational number. So whenever you do division between rational number and irrational number, it will give you an irrational number only. So that means 1 by root 7 is an irrational number, but just denominator you have to rationalize. So entire term you cannot rationalize, because you cannot make an irrational number a rational number. So that's why here they are only asking to rationalize the denominator. So in order to rationalize the denominator, so whenever you have something in the denominator, you can multiply this to both numerator and denominator. So when you do that, you will get 1 into root 7 is root 7. So because I am multiplying and dividing with the same number, the value will not be changed, the value will not be altered, so it remains the same. So root 7 into 1 is root 7 divided by root 7 into root 7 will be there. So root m into root n is equal to root mn. So that means root 7 divided by root of 7 into 7. So 7 7s are 49. So root 7 divided by root 49. So that is nothing but 7. So root 49 is 7. So root 7 divided by 7. So finally you are getting root 7 divided by 7. So here you can see 7 is a rational number. So that means we have rationalized the denominator. So now looking into the second question in the same fifth question, here they have given 1 by root 7 minus root 6. So whenever you have two numbers in the denominator, so that means whenever you have two terms in the denominator, just see what symbol you have here. So if it is the subtraction symbol, you can straight away take plus symbol and multiply that with numerator and denominator. Why we are doing this? Because we know that a plus b multiplied with a minus b will give you a square minus b square. So in order to make a square minus b square in the denominator, we are using this particular trick. So that trick is, you can just take positive value in between root 7 and root 6, that is root 7 plus root 6, and you can multiply this root 7 plus root 6 to both numerator and denominator. So when you do that, here you can clearly see, when you do 1 into root 7 plus root 6, you will get root 7 plus root 6 in the numerator divided by root 7 minus root 6 into root 7 plus root 6. So here you can clearly see you have a minus b into a plus b in the denominator. So that is nothing but a square minus b square. So that means directly you can write this as root 7 plus root 6 divided by root 7 whole square minus root 6 whole square. So that means here you are getting root 7 plus root 6. So root 7 whole square is 7 and root 6 whole square is 6. So 7 minus 6 is there. So root 7 plus root 6 divided by 7 minus 6. So 7 minus 6 is 1. So 1 is a rational number. So that means we have rationalized the denominator. So similarly, you can do the third question also. So in third question also, you have 1 divided by root 5 plus root 2. So here you have plus, so just multiply with, so that is take minus in between root 5 and root 2. So that is root 5 minus root 2 divided by root 5 minus root 2. So when you take root 5 minus root 2, it will become root 5 minus root 2 in the numerator. In the denominator, you have root 5 plus root 2 into root 5 minus root 2, that is nothing but a plus b into a minus b. So a square plus minus b square you can directly write. So that is root 5 square minus root 2 square. So that means here you are getting root 5 minus root 2 divided by root 5 square is 5 minus 2 root 2 square is 2. So 5 minus 2 is 3. So finally you are getting root 5 minus root 2 divided by 3. So here you can clearly see the denominator is a rational number. Similarly, we can solve the fourth question as well. So in fourth question, you have 1 divided by root 7 minus 2. Here also you can multiply numerator with root 7 plus 2 divided by root 7 plus 2. So here you can clearly see 1 into root 7 plus 2 will be root 7 plus 2 divided by root 7 minus 2, root 7 plus 2 is there. Here this is like a minus b into a plus b. So that is nothing but a square minus b square. So that is root 7 square minus 2 square. So this is equal to root 7 plus 2 divided by 7 minus 4. 2 2s are 4. So 7 minus 4 is 3. So root 7 plus 2 divided by 3. So here you can clearly see 3 is a rational number. So we have rationalized the denominator. So this is all there in this particular video. The next concept which is there in this particular chapter and the exercise 1.5 I'll be teaching in my next video, and there comes to an end for this particular chapter. So one more video will be there after this particular video for this number systems chapter. So till then, if you want to learn more physics, chemistry and mathematics like this starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.